The broadcast is now starting. All attendees are in listen-only mode.
Klokken blevet 9. Vi venter lige et par minutter for at se, om der er, eller et minut eller to for at se, om der er flere, der kommer ind her. Jamen, velkommen til det her webinar omkring Integrity Lifecycle Management. Jeg hedder Lisbeth Siversen. Jeg vil lave en kort introduktion, og så overtager Ryan Andersen, som er vores ekspert på systemet, senere og laver sådan den lidt mere dybe info om det her system. Han vil gøre det i engelsk, jeg kører dansk igennem. Så hvorfor er det, man overhovedet vil have sådan et system? Jamen, typisk så er det jo, fordi man har en standard i industrien. Det kan være inden for medical device, defense and aerospace eller bilindustrien. Og der er simpelthen krav om, at det skal man. Men der er ganske mange andre industrier, som efterhånden er kommet til at se, at de også skal følge standarder. Det kan være miljøkrav eller andet. Eller at de har nogle interne krav. Fordi der er ganske mange forskellige typer af krav. Og holde styr på alle typerne og måske få prioriteret imellem de her krav kan være svært, hvis man ikke har et rigtig godt overblik over, hvor kommer de fra, hvordan er de blevet brudt ned til det, der gælder for lige præcis det her design. Og det med, at det er kravene, der skal drive dit design, det er altså vigtigt, at dit design lever op til de krav, der er for det, og dermed løser de udfordringer, lige præcis det design skal løse, er blevet meget vigtigt i vore dage, hvor man ikke bare har en løsning, fordi det var en sjov opfindelse. Det næste er, at man tit, hvis man har mange krav, kan sidde med den her fornemmelse af, at jeg tror, vi tester for meget. Det er vigtigt, at man ved, på hvilket niveau det er, man skal foretage testen. Er det på systemniveau, eller helt nede på det specifikke modulniveau, der skal testes. Og at man ved, hvilke præcis krav det er, man er i gang med at teste. Fordelen ved sådan et system som det her, det er, at man har styr på, hvilke af kravene, der er standardkrav, og dermed kan man have test, som passer præcis til det standardkrav. Næste udfordring er, hvornår er det, jeg foretager min test? Det giver ikke meget mening at lave en modultest efter en systemtest. Så det med at få timet det rigtigt, at man ved, at man har lukket modultesten, før man laver systemtesten og laver brugervalideringen. Hvis man har styr på det, så sparer man ganske meget testtid. Selvfølgelig er udfordringen med at have standarder, det er, at de faktisk godt kan ændre sig. Så de vil udvikles over tid. Det gør de alle sammen. Man bliver klogere, og der kommer andre krav. Problemet er, hvis man har mange forskellige design, hvor er det så, det her slår ind henne? Hvordan ved jeg, at det er lige præcis det her projekt, jeg skal ned og tage stilling til, om jeg skal forholde mig til den nye standard? Her bliver det rigtig vigtigt, at man har et system, hvor man ved, hvor det her er. Hvor skal jeg ind og ændre mit design, og hvor skal jeg ind og opdatere mine test? Derudover så har vi jo, som jeg snakkede om, forskellige typer af krav. Og det at finde balancen mellem de forskellige typer af krav, er noget af det vigtigste, når man laver sit design. Det at få en systemingeniør til at snakke med vores risk manager og lead engineeren, sådan at man har balanceret diskussion mellem, hvad er det for krav, der er vigtige i det her. Ned til, at man også tager med, om de krav, der er fra produktionen, kan betyde, at man skal ændre på metoden, man fremstiller, eller måske outsource. Nu tror jeg faktisk, vi er ved at være klar til at gå over til Ryan. Ryan will do some of the theory behind integrity and go into the deeper innings of it, but we'll also do a live demonstration so you get to see the system, how it works. So I will hand over to Ryan now and hope that he can explain this.
All right, so morning folks, Ryan here. So yeah, you've all tuned in to see a little bit about handling some regulatory requirements, customer requirements, and internal requirements inside Integrity. So I have a couple of little slides in the slide deck that gives a little overview of what that looks like in Integrity, and then I'll do a little system demo to show a couple of these things. So a little overview of what I'll cover here in this webinar. So why Integrity, first of all? So what are the advantages of using Integrity as a requirement and test management tool? So what problems today does the tool help alleviate? And then I'll take a slightly deeper dive into specifically which features and capabilities in Integrity help to achieve that. Then we have a little bit about integrity theory. So there's some sort of fundamental knowledge that gives you an overview of the sort of the data model in the tool, how your requirements relate to one another, and all those kind of things. Then I have a little point here, integrity at a glance. So one specific functionality in the tool called suspect traces. So how does that make it easier for you to see when you change a requirement, what impact does that have on other requirements or tests within your project? And then, of course, we'll finish up with a little system demo in the end. So here we have the V model. Some of you may know about it already. Some of you, this might be completely new to you. So the V model is the verification and validation model. This is commonly used in regulated industries where it's important to verify and validate your requirements via tests, and where it's fundamental to get an overview of traceability between your requirements and tests within your development projects. So let's look at this V model and break it down, see what we're looking at here. So in integrity here, we have this input document. that sits at the top of the V model. In here, we capture the voice of customer. So that could be regulatory requirements, that could be internal requirements, and of course, requirements from your customer. Now, these requirements here, these high-level requirements, are broken down in a requirement specification document. And in here, you capture your product level requirements. And where needs be, we can further break these down into technical design specifications. So exactly which components relating to your product, we can break those down even further, pinpoint design spec requirements to specific components in the product. And then we have test protocol documents and tests where we can conduct module level tests and also product level tests as a whole. So in integrity, there's a terminology called upstream and downstream traces. So downstream traces are going down and to the right of the V model. And when we talk about upstream traces, that's going left and up, so the inverse direction. So let's look at the semantics here and the meanings of these trace relationship names we have here in integrity, because these actually give a really good meaning when we're talking about traces in integrity. We can pinpoint exactly which traces we're talking about, right? So these have very meaningful names between one another. So we have here, we have input requirements. These can be typically decomposed to one or many product requirements, right? And these product requirements can then be satisfied by our module level designs. Now, of course, both our product level and module level designs and requirements can then be verified by or validated by a product level or module level test. And of course, this works in the inverse direction when going upstream. So just found a little mouse here. A test can verify or validate a module, and therefore the module can satisfy the product requirement where that product requirement has been decomposed from a customer input.
I think I forgot to say that you always welcome to put any questions. If there's anything that you want to ask, please just type in the question or unmute yourself. We'll try to answer whatever questions you have. Okay, Ryan.
No worries. So now we take just a little glance at this suspect trace here. So it's a little bit into the deep end, but I think it's good to get a overview of what this is all about before I go and show about it and before I talk about it, as I mentioned it a lot in the forthcoming slides. So let's just become familiar with this data set here so we can understand the suspect traces. So here we have a customer requirement where we've captured that, this system shall be able to capture requirements and test items simply. So we've got a customer input here. This is then broken down or decomposed to a product requirement. And this product requirement suggests that we shall be able to capture business requirements in this system. And then this requirement has been further broken down into a couple of different designs. So this specific design spec says we shall be able to create business requirements via a create item menu. And we shall also be able to create business requirements inside a document. Then we have some tests here. We have our product level tests, the tests that we can just generically create a business requirement, of course, in the tool. And then we have our module level tests where we would like to see that we can test that we can create a business requirement in this item menu and also inside a document. So now where the suspect traces kick in, what happens if we want to update a requirement here? So now we want to be able to create regulatory requirements in this tool rather than business requirements. So we've updated this requirement now. And what integrity smartly does for us is it finds all the related artifacts, our tests and designs that are traced up to this updated requirement and flags those traces as suspect. So this is done automatically here. And then from here, you can go in and look at your suspect traces and see, okay, I have a test here that's testing that we should be able to create business requirements. That's no longer in scope. We want to create regulatory requirements instead. So we know we need to update this test here. The same goes for these two designs here. We want to create a business requirement via this method, this item menu. We need to test that we can create regulatory requirements instead here and also down here. So we update our artifacts here. So we've updated these now. Then what Integrity does again, it'll look at everything related to these updated artifacts. So tests are at the bottom of the V model. There's nothing traced up to that. So we're fine here. But if we look at our designs, we have some tests being traced up to these designs here. So Integrity again will flag your suspect traces for you and say, hey, you've updated designs. You now have some tests that probably also need to be updated as a result of this. So you would look at your tests. You can see again, you're trying to create business requirements via this item menu, and you're trying to create business requirements in the test here in your document. So again, you will go ahead and update your tests. And now here you can get an overview and see that your data set is now more coherent. So you can now clear your suspect traces and you now have a more coherent data set here with no suspect traces. So now we'll just take a little step back and look at some of the high-level advantages of using Integrity as a requirement and test management tool. First of all is data consistency and single source of truth. So using Integrity, long gone are the days where you're capturing requirements, say on sticky notes across multiple people's different desks. You have requirements being discussed and captured in emails and different inboxes, different people's inboxes. Same with your Excel and Word documents being saved on personal drives and shared drives. It's hard to get an overview and a sort of aligned view of exactly what requirements are looking like for a specific product. So Integrity is that single source of truth where you have one database, the Integrity database, that captures all your requirements and tests. Second of all, we have collaboration. So Integrity provides a real-time collaborative editing environment. So multiple engineers are able to work on the same document at any given point in time. And the reason how this is possible is because Integrity, when we edit things inside a document, we lock out a specific requirement rather than the whole document. So multiple people can work on the document at the same time, which means people are aligned on delivering on the same product, the same version of the document. So of course, providing feedback is also very, very important. And that's also very easily done in Integrity. We have a logged comments field on documents, on distinct requirements themselves, where people are able to provide comments directly relating to a requirement. Then perhaps one of the most beneficial advantages is traceability and structure. So first of all, we look at traceability here. So actually, generally, the rule for traceability and Integrity is to link as we think. So link your artifacts as and when you see it being necessary. So you link your requirements to your designs as and when they become available. You trace your requirements and designs to tests as and when they become available too. And this helps us to understand when we create traces and links between our artifacts in Integrity, we can understand why we have specific requirements for our product. So we have a test because we need to verify a requirement, and we have a requirement because my customer asked for this in the product, right? So second of all, we have structure. And I think this systematic structural way of working with requirements management in Integrity helps simplify development of complex products today. So having this more simplified overview, structural overview, you can get a better overview of your artifacts within your development products. So ensuring you're developing on the right product, everyone's aligned on the same document, and this can help you prevent from having design inconsistencies realized earlier, as you're able to get a better overview between your artifacts in Integrity. So we touched upon this briefly with the suspect tracing. So we have the impact of change. So Integrity helps to facilitate a better understanding of changes. So why changes are made, and every change in the system is captured and recorded. So first of all, we have item history. So we have item history on your requirements, your tests. So say your requirement is updated, maybe acceptance criteria is updated, that's captured. If you create and delete traces, they're captured. Maybe we update an expected result on a test, that's captured. So nothing goes amiss in the tool. That's something you take for granted. And of course, that's there in integrity. And then we also have the suspect traces. So again, when we update something in integrity, integrity automatically flags what's affected by this change. And you go in yourself, manually evaluate, is this okay? Then I clear my suspect traces. If not, then I would do something about it. Then granularity. So more now than ever, we have the need for being more distinct and defining our requirements on a more lower level. So, beforehand, it was more than okay to trace test protocol documents to whole requirement spec documents. This is a very high level overview. And nowadays, we have a more of a need to say that this specific test case verifies a specific requirement for a product. Secondly, with integrity, we're able to describe our requirements at a more finer level, finer granularity. So every requirement in the tool has a unique ID. We're able to classify our requirements in the tool. So it could be user requirements, production requirements, and so forth. We're able to add prioritization to our requirements. And by using a mixture of all these different attributes on our requirements, we're able to create some meaningful reporting and dashboards. So we can view things such as how many relevant requirements that are high priority that aren't traced to tests. We can pick that out very easily as we define our requirements at a much finer granularity than before. And lastly, we have the point on reporting. So in integrity, we have a mixture of different dashboards, reports, metrics, and so forth. And all these metrics we get for free in integrity provide a real-time overview of the ongoings within a project. So we can see how many requirements aren't traced. We can see the resource overview of test engineers for testing, and so forth. So now looking at more integrity scope specifically, how does integrity help to achieve this feature-wise within the tool? So first point is traceability. So now today, there's a lot of companies these days that have several Word documents that capture their product requirements, maybe their legislative requirements and their technical design specs. You may have a traceability matrix, which is essentially a grid of crosses that say this test verifies this requirement. So you have numerous amounts of documents. You have to jump between your documents to get an overview of what's traced between what and what's fulfilling what. So in integrity, we have something called the downstream trace view. This is something I'll show in the demo. So this is something that system engineers and requirement authors will very much like. So essentially what we see in the downstream trace view, we can get an overview of all our requirements, how they're being broken down in the project, and what's being verified by what. So we can see this top-down decomposition of our requirements and the traces within the requirements in one single view. So we're able to get a better overview of all our requirements within a given project. So second of all, we have our dashboards and metrics, as I touched upon just before. These dashboards provide a real-time overview of any metric within the projects. So in this particular dashboard here, I will show in the demo, it gives you an overview of how many requirements and designs are untraced. It also gives us an overview of requirements and designs that were updated within the past week. That's a useful metric to know from time to time. So these dashboards and metrics provide real-time overview on your projects. Here, this is a pretty big topic in itself. It's not something I will show today, but it's something I certainly can show in the future. This is something we can talk about in for many, many hours. But in Integrity, we have the capability of reusing requirements and tests. So let's have a little look at this little use case we have here. So in Integrity, we have libraries. Now, libraries are typically document sets. They contain standardized document sets that can be possibly reused between different projects. So an example is a library could contain some generic product line requirements and tests. We can pre-trace those between one another, and then what we can do is we can do something called branching in Integrity. And what that is we can copy this document set down into some variant projects, for example, where they have almost the same requirements with some small variances, and we can get projects up and running quicker than before, and you can maintain this document structure and set with all your traceability within a variant project and make your project specific changes from there. One second. I think we have a little question.
Yes, we have a question here. Does the ConOps and operational scenarios fit anywhere in your process? I think that might be,
I think
we need to look into that.
I think this is something I'll need to get back to you on, for sure. Yeah. Do we have any more questions?
I think I've tried to answer them in the question.
Okay.
Okay.
Get back to you on that one. All right, so now we're looking at integrity structure. So this is just an overview of some of the, you could say, integrity buzzwords and items, how they relate to one another. So this is just almost a quick 5-minute crash course on what integrity is. So first of all, in integrity, we have a product. That product typically represents a product line or product family. Now, this product can be related to many projects, and a project could be a variant project within integrity. Now, these projects hold documents, so we have different kinds of documents, customer input, requirement spec, and so forth. These libraries, they also hold documents, but where the unique use case for that is we typically hold standardized document sets that can be reused within projects. Of course, projects and libraries are governed by security, so obviously confidential information can be hidden and only shown to those on a need-to-know basis, so that's something you would expect, of course. These documents, they contain items or document content items, so requirements obviously live in a requirement spec document, tests live in a test protocol document, and so forth. These items have unique fields or attributes. So for example, on a requirement, you may expect to see requirement text describing a requirement. You may see an acceptance criteria, something the requirement must live up to. Whereas on a test, for example, you may see some descriptions, some instruction for the tester to carry out during test execution. You may see something such as an expected result and so forth. And then, of course, as we know, all these items are linked together via traces, so a mixture of upstream and downstream traces, and this is how we create our sort of coherent story and structure within our product requirements, regulatory requirements, and so forth. Of course, to mention, documents, they can be exported out with the integrity, so people who don't have access to the tool or aren't trained at using the tool, we can export documents out very easily and make those visible and readable to people out with integrity. Now, these items are shown in a view. More specifically, this tiny little picture is showing you the document view. This is something you will see in the demo. A view is something that is a part of something bigger called a view set. And the view set is essentially your user interface in integrity. And this is highly configurable. very easy to show and hide information that you would like to see, that you wouldn't like to see. Essentially, it's a tabled view of different views within Integrity. And also the use case with these view sets is you can tailor your view sets to typical roles within your organization. So you can create a requirement author view set for your system engineers and requirement authors. You can create a test engineer view set for people interested in testing. And this is just to scope information in the system to show information that really people only that's really only of interest to them, right? So it's not to overwhelm people with everything in the system, but so they can only see information that's, of course, relevant to them in their daily business life. Alrighty, so now I'll jump into the little system demo. I'll give it a couple of minutes if we just have any questions. Yeah.
We have one question here. Reusing requirements often requires that you know the functionality of your product you want to design. How does Integrity handle functions and linking the requirements to functions?
Okay, so what do you mean by functions? Is this your design specifications?
I think this is when you have different design solutions and you can assign the same requirement to more than one design solution. So you would have some requirements that goes with views like a string instead of another type of solution.
Okay, so
but it's the same overall requirements that you have to fulfill. But when you break it down, it gets different.
So maybe we're talking about different variants here.
I would assume so.
So yeah, from that question there, I think this is a question about how you describe or document your designs and requirements in your libraries. So typically, they're your standardized document sets. You maybe would have a library for your product line, and in that particular library, you would capture all your maybe design variants and specifications, have those traced to your requirements in your library, and then perhaps from there you can branch that down into your variant projects, and you can pick out which designs and requirements are relevant for your projects there. So just let me know if that answered your question. Otherwise, we can take that again later. Just give another minute for some questions, and then I'll continue with this demo here. Okie dokie. Right, so I'll dive into this system demo here. So just before I dive in here, we'll cover some things. Obviously, the general GUI we're looking at here, just a couple of examples of creating some documents, creating some document content, creating some traces between that content, looking at this downstream trace view where we can see the hierarchy of our requirements. How do we see missing traces and suspect traces and so forth? And then I'll look in some dashboards that we have. So this is what we'll be looking at here. So before we dive into it all and get lost in all the detail, let's take a step back and look at the GUI. So I'll give you a short intro to this interface here and what we're looking at. So I think the most logical place to start from is up here. We have the query field, and this is essentially what we're looking for in the Integrity database. Right now, we're looking for all documents. This is the list of our results here. We could be looking for something different. Let's say we could look for all change requests, for example. We could be more specific in our previous search and look for all requirement specification documents, right? So basically, this is just looking and filtering through the Integrity database. So let's go ahead and use this project filter here. So you can use this project filter as an extra filter on your query. So right now I'm looking for all requirement spec documents in all of these projects. So maybe I want to take this webinar project, for example, to scope my search. So right now I only have one result here. So this is the query results view. So we can see here, querying for all requirement documents in my webinar project returns one requirement document. So I have one requirement document in this particular project. I'm just going to step back and be more generic about my query so I can view all documents in my project here. So down here, we have the item preview window. And what this is, this shows you a more detailed overview of your currently selected item in the query results view. So we get information about, of course, the title of the document, some description, what state is it in, is it published, is it open, what project it's related to, typically assigned user as document responsible, and so forth. And we have some approval fields down here. So let's go ahead and open up this document. So we right click and view documents, because the interface here is a little bit different than this query view. So what you notice here is we have tabs in Integrity. So much like your web browser, you can tab between different views in Integrity. So we can jump back to run another query and return some results here. Or we can look inside our document and make some changes, edits, or whatever. So here we have our document outline view. Essentially what this is your table of contents in Word. So it's your structural overview of your content inside the document. Over here on your right side, this is the document view. So this is all your document contents that contains your metadata and your distinct requirements. So here you can see you have headings, you have comments here. What comments are that they're your metadata within your documents. And here, this distinct requirement line here, this is a requirement that's been classified as a system requirement. So we have system requirement 4247. We have some description on the requirement. Over here, we have some information about the high-level information about traceability. So we have this trace status field. So we can see this requirement has been traced upstream. So it's being decomposed from a customer input, and that has some downstream traces. So it's either been traced downstream to a design or a test. So this gives us a high-level overview of traceability within our document on an item level. Right, so let me go ahead and close this document here, and I'll show you a little example of how we create some documents and some content. So let's go ahead and go to document create. I'm going to create my customer input document within this project I'm using here today. And let's go ahead and call that Ryan's customer input document. Save that there. When we hit OK, that will launch up your document that you've just created. It's an empty document. You may challenge me there and say, hey, it's not empty. We can see a requirement here. What you're actually looking at here, this is something called the virtual row. So it's a requirement that doesn't exist in the document. And we know that because it doesn't have a distinct ID here. So when we create something in Integrity, then we have an ID automatically assigned to this requirement. So let's go ahead and create some content in this document. So I'll create a heading. Let's say requirement spec document. Let's make it look like a heading. And Control S to save. That's a hotkey in Integrity that will be used a lot. And then we can create some metadata in here and say this document contains requirements. Rightio, and save that. Let's create now a meaningful requirement here. And let's say this is a input requirement for my customer. Let's say product lifetime. Let's say this product shall have a lifetime of 15 years. So let's just format that a little bit and save that here. So here we have some content now inside my document, create some structure here. Let's do that. So I have some structure inside my document. So here I have an example of one customer input requirement here. Let me go ahead and just quickly create a requirement spec document so we can create some traces. So again, in the same project, we'll call this Ryan's requirement spec document. Again, Control S to save and create, and OK to launch the document. And let's go ahead and create some, again, just a heading. So let's make it look like a heading. Again, just some metadata as you normally would expect in a document. And then let's create a couple of product requirements here. So let's classify these as system requirements. So we have one here, let's say battery lifetime. Let's say the battery shall have a lifetime of greater than or equal to 15 years as an example. So we save and submit that. Just do a little formatting here. And let's create another requirement. Let's say mechanical durability as an example. And say the frame of this particular product shall be able to withstand a force of greater than or equal to 80 newtons in this example. So here we have now two requirements in our requirement spec document. So the next thing is we can create some traces between our artifacts. And the way we do that is, or the preferred method is we can set our documents side by side. So here we have our customer input document capturing our customer requirements, and we have some product requirements over here. So there's many ways to create traces in Integrity. This is my preferred method. So we can create traces by holding Alt, dragging and dropping a requirement on top of a requirement here. We can see the create trace, hover over here. So we release that. We get a confirmation message saying we're creating a trace from that requirement to our other requirement. So we can confirm that here. And we can also create our traces, obviously in the other direction here. We get a confirmation message. So now if we navigate over to our trace status field on our customer requirement, we can see it's been broken down by some product requirements. We don't know exactly what from here, but we know it has some traces. So let me just close this here so we can see a little bit more. So we can see it's been traced downstream. And if we go to our traces tab here, we can see the two requirements we just created a trace to. And if we would like some more information about these, we can right click and view the document there inside, and it instantly highlights the requirements that we've created the trace to here. Alrighty, then let me close this up here, and let me show you an example of this downstream trace view. So when I hit F5, we can see here, we can see the two new documents here. I think this particular document is a suitable candidate for this here. So let's see what's been traced downstream here from this design. So downstream from a design is all our verified by tests. So we can generate that there by going here. Here we have our downstream trace view. And here we can see we have some designs here. This is all designs inside our documents. So this particular design has been verified by this set of tests. This one being verified by this set of tests. And at a glance, when we look through this downstream trace view, we can see our designs look like they're traced to tests. They're being verified here. But this particular one at the bottom here, we can see this design hasn't been verified by a test here. So from a graphical standpoint here, we can see, okay, this design's missing a trace. The test here has not been verified. We need to make sure this is done. You can see over in the trace status field, yeah, this design has an upstream trace, but it's missing, you can see the downstream trace, the verified by trace here. So we know that this design from this particular view is missing some verification test here. Okay, so I'll finish up this this demo here. Had a little bit more to show, but I think we're running out of time here. So maybe at a later date I'll finish this up at some point. So if you have any questions.
I can unmute you all, so let's hear if there are anybody who have a quick questions. But let's see here. There's no questions here, but we have one. How do you design? How do you trace to a design in PLM? So if you need to trace to, for example, Windchill, you'd have to have an interface from Integrity to Windchill. It's a standard thing that you can get from PTC. And Windchill is prepared for this and can link directly into a tab. So you, on your design, you see what requirement is for this.
I'll add a little extra to that. So basically in Windchill, when you install the Navigate app, manage traces, there's a little action on a WT part where you can launch an integrity requirement document or design document, and from there you can create your traces distinctly from Windchill to a design or a requirement to that WT part. So you create relationships from your WT parts to your requirements and integrity.
And another question here. Is it possible to go further downstream from test protocol to test report? And can you link the test report to the different version of the design?
Yes, so this is test management related question. So when you run tests in integrity, you have these test run items, and you have some information on there that says that this test run is valid as of a specific date. So the test you put up for test execution, we get this little snapshot saying the results of this test are valid of a specific date, and these tests will be traced to designs and requirements, so you will know which iteration and version of the designs this test result is applicable for.
The question is the link to PLM design also marked as suspect at requirement change?
This one, I'm not too sure actually, and I will get back to you on that one. I will have a little look, and I will get back on that one. It's a good question.
I think that was the last question, and we'll thank you all for attending this webinar. And please let us know if you have more questions. We can get back to you and try to answer those. Thank you for attending it.
Thank you, everyone. See you later.